Hello, I'm Kirk Weiler, and this is Common Core Algebra 2 by eMath Instruction. Today, we're going to be working with Unit 10, Lesson number 9 on complex fractions. Now, fractions are rarely anybody's favorite topic in mathematics, and now we're going to introduce something called a complex fraction. So without further ado, let's get right into what a complex fraction is. Well, a complex fraction is a fractions within fractions. So it's a fraction that has fractions in it. Remember, fractions are division problems, so there's no reason why you couldn't have like division within division. Now, sometimes complex fractions like the one that just showed up, 1/4 plus 2/5 divided by 2/3, well, those are, all numerical. But of course, the ones we're going to be dealing with today are fractions that have fractions in them with variables. Ultimately, what we'll be working with today is how to simplify complex fractions. And what it means to simplify a complex fraction is to simply write it as a single fraction, so no fractions within fractions, and in simplest terms, in other words, factor cancel. All right, now the keys to simplifying a complex fraction are going to be similar to the keys to adding and subtracting fractions. All right, so let's jump into exercise 1, where we look at a numerical fraction and see how to simplify it. All right. Exercise 1. Consider the complex fraction 1/9 plus 1/18 divided by 1/3. Okay, I will consider it. Letter A. What is the least common denominator amongst the three minor fractions? In other words, the 9, the 18, and the 3. What is the least common denominator? If you were going to add those all up together, what denominator would you use? All right. And we would use 18. That is the least common denominator. Let me get rid of all that. Now letter B says multiply the numerator and denominator of the major fraction by your answer in part A and then simplify your result. In other words, we're going to do the following. We're going to take 1/9 divided by 1/18, plus 1/18 divided by 1/3. And I'm going to multiply the numerator by 18, and I'm going to multiply the denominator by 18. Now, when I do that, I have to distribute. Okay, and this is important because I'm going to have 18 times 1/9 plus 18 times 1/18. We're going to speed this up in future problems, but I really want to write it out very carefully right now. The reason I can do that is then 1/9 times 18 is just 2, and 1/18 times 18 is 1. 1/3 times 18 is 6. So in the numerator, I just get 2 plus 1, which is 3, and in the denominator, I get 6. Now obviously I can simplify that result and just get 1/2. I bet it wasn't obvious that that fraction, that complex fraction, was equal to 1/2. Now, more important than the fact that this was the least common denominator was the fact that 18 canceled 9, 18, and 3, right? It canceled all of them. It got rid of all the small denominators. Letter C is important, right? Because you don't want to just learn this as, oh yeah, just do this, memorize it. Letter C says, why is it acceptable to perform the operation in part B? What number are you effectively multiplying by? Well, by multiplying both numerator and denominator, or top and bottom, by 18, we are multiplying the overall fraction by 18 divided by 18, which equals 1. I would say that 95% of the algebraic manipulation you do with fractions boils down to either multiplying by the number 1 or getting rid of all sort of like factors where something divided by something is equal to 1, right? That's the simplifying piece. So it's really, really important to see this big picture. constantly multiplying numerators and denominators by the same number, okay, in this case being 18. We're now going to segue, though, into a portion where we have variables involved as well. All right, so pause the video now, take a look at everything that we've done before we move on to the variable expressions. All right, clearing it out. Let's take a look at the next problem. So in exercise 2, it says simplify each of the following complex fractions. Now, letter A is very, very similar to the one that we just did because it's all numerical. So pause the video now and see if you can do that one, and then we'll extend it to parts B and C. Okay, well, really, what I want to think about mostly, you can think about common denominators, but what I like to do is look at the 2, the 10, and 5 and think, what would cancel all of those? And what would cancel all of them is a 10. So I'm going to multiply the numerator by 10, and I'm going to multiply the denominator by 10. Now the numerator is more complicated, it's a binomial. But when I multiply 10 by 1/2, I get 5. And when I multiply 10 by 1/10, I get 1. When I multiply 10 by 2/5, that's a little more complicated, but I get 4. I then combine in the numerator, 4 divided by 4, hey, I get a nice answer, the number 1. So 1/2 minus 1/10 divided by 1/5 is 1. Now, let's take a look at letter B. Here, I'm looking at 3, x, 3, and x. If I was going to combine these by adding, my least common denominator would be 3x. So that's what I'm going to multiply everything by. I'm going to multiply the numerator by 3x, and I'm going to multiply the denominator by 3x. Now, I'm going to write out the next step, okay? I'm not going to just do the canceling and write the result, but I'm going to actually write out the next step. Because again, I want you to really understand what's going on here. We're multiplying by the number 1 in a very, very sort of crafty way. We're doing it in a way to eliminate all the denominators. This is important for higher level math. So when we look at that numerator, these 3's cancel. Here, these x's cancel. We're cross-canceling. Remember multiplying fractions not that long ago? Here the 3's cancel, and here the x's cancel. So what do I have left? Well, here I have 2 times x, or 2x. Here I've got 3 times 2, which is simply 6. Here I've got 5 times x, which is 5x, and here I have 3 times 5, which is 15. Now the only question that remains is, can I simplify anything? And that then boils down to factoring and canceling. The numerator I can factor as 2 times x plus 3, and the denominator I can factor as 5 times x plus 3. So the x plus 3's cancel. I'm going to save myself a little writing. The final answer is 2/5. Isn't that great? All right. I'd like you to pause the video and take a shot at letter C. Okay, let's go through it. Again, I'm looking at an 8. I'm looking at a 4x. I'm looking at a 2x. I'm looking at a 4. What's going to cancel all of them? That's one way to think about it. Another way to think about it is, what is the least common denominator? All right, and 8x is going to cancel all 4 of those quantities. So I'm going to take an 8x and I'm going to multiply it by the numerator. And then I'm going to take an 8x and multiply it by the denominator. All right, now I'm going to distribute and I'm going to see what I can do. All right, in this first case, 8 and 8 cancel, and they'll leave me with 3x. The second one's a little bit trickier because the x's will cancel, and the 4 will cancel into an 8, but I'm still going to be left with a 2, not a 2x. A factor of x cancels a factor of x here, and it's just about the 8 and the 4 at that point. Down here it's even a little bit trickier because the x's will cancel, and the 2 and the 8 will cancel, but that will leave me with a 4 times 7. I'm going to leave it that way. Plus, and in the second case, right, the 8's going to cancel with a 4, but it's going to leave me with 2x times 3. I'll clean this up now. I've got 3x plus 2 in the numerator. And of course, write out more if you need to. Write out as much as you need to. And then I have a 6x plus 28. Right, here's my 28, and here's my 6x. Now, there is some factoring that can be done in the denominator. We could pull a 2 out of both of those, and that would leave me with 3x plus 14. But notice that 3x plus 2 and that 3x plus 14, they don't cancel each other. So we can actually leave our final answer just like that. I had to look at my final answer just to make sure I hadn't made a mistake, but that's it, right? Notice in each case we started off with complex fractions, fractions that had fractions within them, and we ended up with just sort of normal fractions, right? Single numerator, single denominator. All right, pause the video now and write down anything you need to. Okay, let's clear it out and keep going. Backside of the sheet. So these problems can get more complicated. Obviously, they can get quite complicated. These problems, the next 3, involve quantities with x squared in them. So let's jump right into them. Let's take a look at all the little denominators. I have a 2, I have an x squared, I have a 2x, I have an x squared. What's going to cancel a 2 is a 2. What's going to cancel an x squared is an x squared. But an x squared will also cancel an x. So I'm going to use 2x squared. All right. And I'm going to multiply that by the numerator and by the denominator. Now I think maybe I'll write it out a little bit more this time. So when I distribute, I'll have 2x squared times 1/2 minus 2x squared times 2 divided by x squared. Again, you write out as much as you need to, but know yourself. If you make a lot of mistakes, then it's good to write it out. One of the things that will drive math teachers nuts is when students say, well, I know how to do it, I just don't feel like writing it all out, and then they get the problem wrong. It kills us. Anyway, let's take a look at what we can cancel. If we've done our job right, all the small denominators will go away. So this 2 cancels that 2. Great. This x squared cancels that x squared. Awesome. This 2 cancels this 2. Good. And a single x here will cancel a single x here, but we'll still have an x to the first. Here, an x squared cancels an x squared. And let's see what we have left. Well, up here we've got this x squared left minus 2 times 2. And the denominator, I've got this 3 left and this x to the first minus 3 times 2 minus 6. Question, can we simplify? Well, that's a question of factoring and canceling. So x squared minus 4 is x minus 2 times x plus 2. 3x minus 6 is 3 times x minus 2. Cancel. And we get x plus 2 divided by 3. Awesome. That's pretty cool, isn't it? I like complex fractions. They're kind of fun. You know, you identify what's going to cancel all the small denominators, multiply the numerator and denominator by that quantity. Once you've simplified all of that, you then try to simplify the final fraction. So, take a try at letter B on your own. Okay, let's go through it. This is pretty easy. I've got a 5, an x, a 5x, and an x squared. It's going to all be about 5x squared. So in fact, I'm going to start with this line. I'm going to take 5x squared, multiply it by 2/5, and 5x squared, and multiply it by 2 divided by x. So I'm already distributing it, in other words. Then I'll have 5x squared times 1 divided by 5x minus 5x squared times 1 over x squared. All right, let me draw a little dividing line here so we don't confuse the two problems. Let's do some canceling. The 5's cancel, and we're left with 2x squared. Here, an x cancels an x, and I'm left with 2 times 5, which is 10, times x, which is, well, just x. Here, an x cancels an x, but I still have an x to the first, and a 5 cancels a 5, so I'm left with that x to the first. Here, x squared and x squared cancel, so I'm left with x minus 5. That's gotten rid of my complex fraction. The only real question then is, can we simplify it further? That numerator, I can factor out a 2x, and it'll be 2x times x minus 5. In the denominator, there's nothing I can do, just x minus 5. Look at that, cancel. And I'm left with 2x. Isn't that cool? That entire fraction is equivalent algebraically to 2x. Isn't that amazing? If I took any value of x and I plugged it into the original fraction, and then I plugged it into the other one, except for x equals 0, any other number would give me exactly the same result. It's really cool. All right, take a look at letter C. It seems awfully complicated, but it's not that bad. So play around with letter C on your own. Okay, let's go through it. There's a very nice result to this one as well. Let me give myself a little extra room. Hopefully you figured out that you'll have to multiply everything by 12x. So again, I'm going to start immediately with the distributing. So every part of that numerator gets multiplied by 12x. And every part of the denominator gets multiplied by 12x. Now 12x isn't the only thing you could use. You could use 24x, you could use 36x squared, you could get crazy. 72x. A lot of students like to take all the denominators and multiply them together and to get a result that way. But I don't know if that's absolutely necessary. Again, think about the least common denominator and it'll give you the easiest thing to work with. But let's start to cancel. In this first fraction, we get 12 canceling 12, and that leaves us with x times x, which is x squared. Be careful, don't make that into a 2x. Then in the second one, we've got a 12 canceling a 6, leaving us with a 2, and times x gives me 2x. In this last one, we have an x and an x canceling, leaving me with 2 times 12, which is 24. All small fractions are gone. In the denominator, I'll have a 12 times cancel a 12, and I'm left with an x times x, which is x squared, minus, here I have a 3 into a 12, whoops, gives me 4. Let's try to make that into a 4. And x cancels an x, so we have 4 times 4, which is 16. Our complex fraction is now gone, but we may be able to simplify if we factor. What would that be? 8 and 3, 6 and 4. I think it's 6 and 4. Right, 2x, yeah. And then x plus 4, x minus 4, boom, cancels. We get x plus 6 divided by x plus 4. Wow, there they are. Don't cancel those x's. Don't reduce that 6 over 4 into a 3/2. Remember, only factors cancel factors. Okay, and that can't be factored anymore. Pause the video now. Write down anything you need to. What in the world was that? All right, let's keep going. Strange sounds that show up on my videos. All right, let's take a look at exercise number 4. Now, this is the most complicated scenario. The most complicated scenario is one where you have to factor some of the small denominators first. So in exercise 4, letter A, what we've got is the numerators perfectly good, right? The numerators, denominators, the small fractions in the numerator have very simple denominators. No big deal here. X plus 2, x minus 4. But in the denominator, 12x minus 24, this denominator can be factored. And to no great surprise, it ends up being factored with those two denominators. Now, what's really nice about this is it gives us a clear-cut sense for what we should multiply the top and the bottom by. Now, it's more complicated, but in order to cancel an x plus 2, I've got to have an x plus 2. And in order to cancel an x minus 4, I've got to have an x minus 4. So I am literally going to multiply top and bottom of this fraction by x plus 2 times x minus 4. All right, now I'm going to write this all out in its gory detail so that you can really see what's going on. So I have x plus 2 times x minus 4 times 4 over x plus 2 plus x plus 2 times x minus 4 times 2 over x minus 4, all divided by 12x minus 24 divided by x plus 2 times x minus 4 times x plus 2 times x minus 4. Whew, let the canceling begin. X plus 2's cancel. And what am I left with? Well, don't forget to distribute. I'm left with 4x minus 16 plus x minus 4's cancel, and I'm left with 2x plus 4, right? 2 times x, 2 times 2. And here, everything cancels. And I'm left with 12x minus 24. All right, let's combine some like terms in the numerator. 4x and 2x is 6x. Negative 16 and positive 4 is negative 12. And then we have 12x minus 24 in the denominator. Seems like I might be able to do something here. Factor a 6 out of that. Factor a 12 out of that. Oh, you've got to be kidding me. Look at this. And this. That entire fraction is equal to 1/2. Oh my goodness. That whole thing is equal to 1/2. Unbelievable. But kind of cool. All right, pause the video now, write down anything you need to, and then I'm going to have you do letter B on your own. Okay, let me clear out the text. Let me try to clear out the text. Let me continue to try to clear out the text. Oh, got some issues with this video. All right, letter B is very, very similar. Now, one huge caveat, subtraction. Be careful. Be careful. All right, pause the video now and take upwards of 5 minutes to work on this problem. Okay, let's go through it. Again, because those denominators, because that denominator in the large denominator, see how hard it is to even talk about this? Because this thing can be factored, I'm going to factor it. Now, that x squared minus 4, that can also be factored, as you all well know. To think about how to factor the x squared plus 8x plus 12. We can also factor this, and we eventually will, but not right now. Right now, I'm going to leave that just alone. Okay? Now, what happens here is very similar to what happened before. It's pretty obvious that what I need to do is multiply both top and bottom of my overall fraction by x plus 6 times x plus 2. Now I'm gonna take a little bit of a shortcut here. All right. In the next step, when I multiply this fraction by this quantity, the x plus 6's are going to cancel. And I'm going to be left with this x, and it's going to be multiplying that leftover x plus 2 minus. In this case, the x plus 2's will cancel, and I'll be left with negative 1 times x plus 6. In the denominator, everything cancels, and I'm left with x squared minus 4. Now at that point, I've eliminated the complex fraction but I've got more algebra to do. X squared plus 2x minus x minus 6 all over x squared minus 4. Combine like terms, x squared plus x minus 6 over x squared minus 4. And now the only question is, can it be simplified? Well, let's try again. Let's see, what would I have? I'd have x plus 3 times x minus 2. That would be the numerator. The denominator would be x plus 2 times x minus 2. Difference of perfect squares. Cancel. And we have x plus 3 divided by x plus 2. Awesome. Still the same as what I got on my worksheet. All right. So pause the video now, write down anything you need to, and then we'll wrap up this lesson. Okay, clear out the text. So today, we looked at what a complex fraction was. In other words, a fraction that had additional fractions in it. That's kind of like dividing by division, right? There's stuff that you can do with it. You can change it, you can modify it. And we found that to simplify a complex fraction typically took a nifty little trick. And that trick was to multiply the numerator and the denominator by the same quantity, always, 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 and by a quantity that would cancel out all of the small denominators, okay? Very often teachers talk about that as being the least common denominator of all the fractions. The least common denominator certainly works, but actually any common denominator works. So think about that as you work on the homework. For now, I'd like to thank you for joining me for another Common Core Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.